In the diagram, the vertices A, B, C are concyclic. Now, I'll be honest with you, in all my years of teaching, I've never heard that word before, so I had to quickly go research it. Don't know why they're trying to be so fancy. It just means they're on the same circle, okay? So EB and, okay, then they said that EB, where are you, EB? There you are. EB and where's EC? There you are tangents to the circle. T is a point on AB such that TE is parallel. Okay, so they parallel, and then that's all fine. Then the first question. I forgot the mark allocations here, but I did go have a look at them quickly. I just couldn't, I didn't have time to put them in. But this one is worth 4, and this one is also worth 4. Oh, by the way, these questions do carry on. We've got more questions on the next slide, 11.3, 11.4, and 11.5. So it says that, prove that B1, where are you, B1, is equal to T3. T3, where are you? There you are. Okay, I saw it. It's a pretty quick one, actually, guys. So what we know is that you could use C3 or you could use B1, but I'm going to start with B1. Now, B1 is the angle that is between a tangent and a chord. Now, remember, when you have something like that, where you have a chord, a tangent, and an angle, then you must think about the tan-chord theorem. So what you do is you take one of your fingers and you place it on the C over here, which is the one side of the chord, and then you place another finger on the other side of the chord. And then you try to bring your two fingers to touch each other, or to get to the same place, for example. So for example, some of you might say, okay, well my two fingers could obviously go along those two lines and they would meet up over here. Now that's not wrong, but that's not what we want. We want them to come together somewhere on the edge of the circle. So go along this line with your fingers, or one finger, and then go along this line with the other finger. Bam! There we go. So that means that angle A, is the same as angle B1 because of the tan-chord theorem. So that's the first thing we could say. We could say that angle B1, let me write in red, is equal to angle A1, and not A1, just A. And that is because of the tan-chord theorem. Okay, so that's the first step. The next thing is that, I don't know why this is worth 4 marks. This is pretty straightforward. It's not a lot of steps. Look at these parallel lines. So can you see there's a corresponding angle over there? So we can then say that angle A is the same as angle T3. And that's just because of corresponding angles. So we can say corresp angles. And that's just because the line TE is parallel to AEC. So therefore, angle angle A is equal to angle T3. So now, can you see the match over there? So we just said that angle B1 is the same as angle A, and then we said that angle A is the same as T3. So the logical conclusion from that is that therefore, angle B1 must be the same as T3. And there's no reason for that part. That's just a conclusion from the steps we've already said. Okay, so for 4 marks, not that many steps. I went and looked in the memo just to see how the whole 4 marks was, and for this one they did one for the statement and the reason, then the statement and the reason. That's where the 4 marks came from. Okay, so just remember that these two are the same. They possibly might ask us to, or we might have to make use of that in later questions. The next one says prove that TBEC, so let's go TBEC is a cyclic quad. All right, so how do we prove that something is a cyclic quad? Well, 3 different ways. Let's actually just do here and then here. Okay, so the first one, most basic one, is if you have a cyclic quad, or if we're trying to prove that it is a cyclic quad, then if the opposite angles add up to 180. Okay, so if those add up to 180, actually let's just say A and B, so A and B. So if A plus B equals to 180, then it's a cyclic quad. Next one, if the exterior angle is the same as the interior angle, so if they are equal to each other, then it's a cyclic quad. Now listen up. The third one is the most popular one, and it goes like this. It's usually when you have some type of cyclic, or they say it's a cyclic quad, or we're trying to prove it's a cyclic quad, sorry, and then it's got lines going across like this. Okay? if that happens, and look here, we also have that happening over there, then usually it's going to be option number 3. So how does it work? Well, it's the angle in the same segment theorem. So what you try to do is you either try to show that these two are the same, or it could be these two that are the same, or it could be these two that are the same, or it could be these two that are the same. See, it's like the whole bow tie thing. See there? So you've got, okay, so it's, whoopsie. So it's the bow tie that is going on, okay? So in this diagram, what that would mean is that it would either have to be this one and this one that are the same, okay? Because that's like a bow tie over there. Or it could be like, for example, this one and this one. Or it could maybe be this one and this one. Or it could be this one and this one. So it's the whole bow tie thing happening. How am I finding those little angles, by the way? It's very simple. Let me show you. I start off with a single chord. So maybe I start off with this side of here. And then what I do is I just try and make angles with that. So I can make an angle there. So that one. And then I try and make more. So I go there. And there, so it would be that one. So it would be those two. Okay, so that's sort of what I'm doing. And then what you do is you'll just go to this one and do the same thing, and then you go to this one and do the same thing, and then go to this one and do the same thing. So those are the different pairs that we could get. So my advice is that if there's a shape that has some lines going through it, then it's normally going to be number 3, and that's where I would always start. Alright, so this is actually quite an easy one. So these lines, BE and EC, they have the same length. Why? Because they are tangents that come from the same point. Remember they told us that they are tangents. Where did they say? EB and EC are tangents, and they come from the same point. So EB is the same length as EC. Why? Tangents from common point. Okay, so what that then means is that in this triangle over here, this angle and this angle would be the same, just because of it's an isosceles triangle. So we could say that angle C3 is then the same as angle B1. That's just because of angles opposite equal sides. Okay, if you're in the IEB curriculum, you are able to just say isos triangle, but in the CAPS curriculum, they are not allowed to do that. Okay, so C3 and B1 are the same. There we go. Now, all of a sudden, these two angles are the same, because we knew from earlier that these two were already the same. Now, that is exactly what we wanted, because if I then actually look at this cyclic quad, and I use this chord as my reference, then look at the angles I can make. Let me show you. I can go this way, and I can make this angle, okay? So I made this angle, and then I could also go this way, and I could make this angle. So if those two are the same, then it's a cyclic quad, and boom, they are the same, so it is a cyclic quad. So what I do now is I say, therefore, angle T3 is the same as angle C3. Therefore, this thing TBEC is a cyclic quad. And the reason is it's the converse of angles in the same segment. Now, for the next questions, always remember everything that we've already proved is the same. So for example, we know that this angle is the same as this angle, which is the same as this angle, which is the same as this angle. We also proved that this shape here is cyclic, because we might need to use this information again, okay, in the next questions. So the next one, for only 2 marks, prove that ET, where's ET? ET, there you are. Okay, so ET bisects angle BTC. BTC, okay, let me get a different color. So here's BTC. So they want us to prove that this purple line bisects that green angle. So what they're actually saying is they want us to prove that these two angles, T2 and T3, are the same. That is what they are actually wanting, okay? So they don't write this in the exam, but this is just for us. They actually, or what do I have to write like that? To say goal. Our goal is prove that T2 is the same as T3. That is what we would love to be able to do. And look how easy this is. Remember, it's a cyclic quad. Now, whenever you prove something's a cyclic quad, very often they like to ask questions about that afterwards. So if you use this as your chord in that cyclic quad, then just go do the whole angles in the same segment. Well, that would take you there. And then if you do another one from the same chord, it would go there. And those two have to be the same. But this one already has that little red dot, which we've proved earlier. So that means that T2 is also going to have a little red dot. So it's also going to be the same. So what we can say is that angle T2 is going to be the same as angle B1, right? We just showed that these two are the same. Why? Because it's angles in the same segment. We can say that because it is a cyclic quad. And when it's a cyclic quad, all of those properties are now true. So we know that T2 is now this one. And then we can just say, therefore, T3 and T2 are the same. Because we already proved way earlier that T3 and B1 were the same. We did that in previous questions. So we can then just say, therefore, T3 is the same as T2. Okay? And then we can just say, therefore, ET bisects BTC. Next one. If it is given that TB is a tangent to a circle through BFE. Okay, so TB is a tangent to the circle through BFE. Okay, so we've got to go make a nice triangle through BFE now. Okay, so something like that. Okay, so what do they want? If it is given that TB... Oh, they're saying TB is a tangent. Okay. So TB is a tangent. Hashtag tan chord. Just saying. Here's a tangent. Okay, so that line is a tangent. Prove that TB and TC are the same. TB and TC. Okay, so they want us to somehow prove that this length is the same as this length. Okay, so what that... well, usually, if two sides are the same, like if let's say this one is the same as this one, then it's usually because these two angles are the same. Okay, so that's probably what we're going to do. So if we want to prove that TB and TC have the same length, then it would mean that this angle and this angle, because that's inside this triangle, they would probably have to be the same. And that's possibly what we're going to have to go and prove now in this question. Okay, so I would go straight for that tan chord theorem, and that'll probably be our fastest method, or exactly what we need to do. So how does the tan chord theorem work again? Well, you need three things. You need a tangent. We've got that. Then you need a chord. Okay, let me do it in green. We need a chord. And we need an angle, which is in between the tangent and the chord. So from that, you can use your tan chord theorem. So remember, we're only working in this red circle. We're not working in the big circle. So you take your fingers, or a finger, and you place it on one edge of the chord. And then you place your other finger, or a different finger, on another edge of the chord. And you try and make those two fingers come together at a point on the edge of the circle. So for example, you could go there, and you could go there. Okay, so E2 is the angle. So that means that E2 and B2 are the same. So let's start there. I don't know if that's going to help, but I think it probably will, because it's usually what happens. So E2 is the same as B2, and that's just because of the tan chord theorem. Okay, so those two are now the same. Okay. And then what I noticed immediately was that these two things here seem to be sticking out somehow. So remember that cyclic quad we found out earlier? So this is the lesson for you guys for this video. If they've asked you to prove something in the past, don't forget it, because they like to come back to it, especially these cyclic quads. So because it's a cyclic quad, we can use angle in the same segment. So if you use this as your chord, then check the different angles you can make. If you go this way, you can make this one. It's the bow tie, guys. You know the bow ties? And then if you go this way, then you could make this angle over here. So those two are then the same. So we could say that angle C2 is equal to angle E2. And that's just because of angles in same segment. Some of you might be like, yeah, but this isn't even a circle. I understand that, guys, but if it's a cyclic quad, then it classifies, you can use these rules. It doesn't have to be in a circle for it to be only, it doesn't have to only be in a circle for it to be a cyclic quad. Okay? Right, and so once again, if you look carefully at what we've done here, we started off by saying that angle E2 and B2 are the same. So B2 and E2, we said that they were the same. Then we said that C2 is the same as E2. So because E2 is shared by both, then we can say that these two are now equal. So we can say, therefore, C2 must be the same as B2. And there's no reason for that. That's just from the previous statements. And that's what we originally wanted, guys. Remember, we wanted to show that this angle was the same as this angle. Because if this angle is the same as this angle, then it means that in this triangle, these two lengths would have to be the same because of angles opposite equal sides. So we can say, therefore, TB must be the same as TC. But don't say angles opposite equal sides. It's because they are the sides that are opposite equal angles now. Okay, they are the sides that are opposite equal angles. The last question says, prove that T is the center of the circle. Okay, now this question I don't really agree with because they don't really teach us this, but for something to be the center of a circle, it has to obviously, it has to be the same distance from 3 different points. So for example, if that's A, that's B, you need a third point that it's, so these, all 3 of these must be the same length. Then we can say it's the center of a circle. It's not enough to only have 2 points, because I could, for example, say that this is the center because these two are the same, so they're the radii, but that doesn't make any sense. So you need a third point as well, and you can see that that's not the same length. So it has to be from 3 points, a minimum of 3. So there, and then there, for example. If you can get 3, then it's the center. Because what some learners might do is they'll say, oh, okay, it is the center. Why? Because this length is the same as this length, because we already proved that these two are the same. But that's not true. You need at least 3. Because as I said just now, you could then say that this is the center because these two are the same, radii, but that's not true. Okay, so it's not going to be difficult though, because what we can do now is we're going to go for this one here. We're going to try to see if this one is the same as this one. Because if this one is the same as this one, and this one is the same as this one, then all 3 of those are the same, and then we're good to go. So let's try see if this side here, is the same as this side. And the way that we do that is just using angles. So let's go for C1. Let's see if we can find C1. So, okay. These are parallel lines, right? So we can just use alternating angles there for T2 and C1. So we can say that angle T2 is the same as angle C1. And that's just because of alternating angles, because of TE being parallel to AC. Okay, so they are the same. And then it's easy. Because these 2 angles are the same, then it means that these 2 sides have to be the same. So therefore we can say, therefore, angle T, or sorry, no, length TA would be the same as TC. Why? Because they are the sides that are opposite equal angles. Okay, so these are the same. And so there we have it. We can see that the point T is the same length from A, same length from C, and the same length from B. So then we can say, therefore, T is the same length or the same distance from A, B, and C. Therefore, T is the center of circle. If you didn't understand this last one, I wouldn't worry too much about it. I've never seen them ask something like that before. It is a bit of a weird question because they don't really go through that in class. So if you did struggle with this last one, 11.5, I really wouldn't stress too much about it.